Hey everyone, and welcome to the second part in our Devolutions PAM series. In our previous video, we introduced our AnyIdentity PAM provider, highlighting its unique functionalities and the flexibility it offers compared to traditional built-in PAM providers. Now, if you haven't watched that video yet, I highly recommend viewing it first since it sets up some key concepts we'll build upon here. You'll find it linked in the YouTube card above. Now, when it comes to productive PAM solutions, adapting to your organization's needs is essential. With AnyIdentity, that adaptability is at your fingertips. So today we're going to dive into the core scripts of the AnyIdentity template, guiding you through its three fundamental actions: account discovery, the ability to find accounts and import them into your PAM vault; heartbeat, to verify that the password of the privilege account and the provider are in sync; and password rotation, to manually reset passwords, have them automatically rotate when checking in a privileged account, or schedule them to update automatically. Now, once you've got a good handle on this concept, you're going to want to check out the next one in the video series, where we'll explore password propagation, the next level of securing your critical accounts, as we'll explore how Devolutions PAM can automatically push and update passwords across all your connected systems. But before we get to that, let's go behind the scenes of the AnyIdentity provider template. To set the stage, in the previous video, I imported an AnyIdentity template called Warehouse Database into the PAM section of my Devolution server. Today, we're going to take a closer look at the various actions contained in this template. Now, it's important to note that the parameters and logic I'm using here are specific to my Warehouse SQL database, and your scripts will almost certainly look different depending on the systems you're managing. That said, the main focus here is to help you understand two critical things: what inputs the script requires to get started, and what outputs Devolution server expects to see for the action to succeed. Now, everything in between, the hashing, database connections, other logic, and so on, will depend on the specific needs of your target systems. So, starting with the first action, account discovery, our script will be fetching data on user accounts like name, role, and so forth from the provider, and then Devolution server will expect to receive that list of users with specific properties. All right, let's go see this in action. So starting in the DVLS interface, we'll go to administration, then privilege access, then providers, and finally the AnyIdentity templates. And then I will go ahead and edit my warehouse database template that I have. We'll start off in the account discovery tab. Now here you're going to see various parameters that we're going to use to map the properties of the provider and or the account that the PowerShell script will be using. So we have the name column, which is the name of the variable in the script. Then we have the source, if the value is provided by the provider or the account. And then we have the property, the source property that will be injected into the script. Now, since in account discovery, we're merely wanting to find and import accounts, we aren't checking or changing any passwords. So all the parameters are set at the provider level rather than on individual accounts. Essentially, we're just setting up the connection for the MS SQL database. As we scroll down, you'll see we're mapping the parameters for the PowerShell script with most fields as strings, except for the database password, which we're using the secured string. Here, we're also going to verify that we're running PowerShell 7.4 or later, and also ensuring that TLS 1.2 is in place. Although it is more of an extra precaution, it's good to have everything double checked. So for security, we've scoped the execution policy as well to just this process and set it to remote signed. Next, we're importing the DBA tools module, which will handle our connection to the SQL database. Now, in your case, you could import any module that you may need to perform your various actions. So a lot of flexibility for you to tap into. Next up, we need our script to create a new SQL credential, then connect it to the MS SQL database using the connect DBA instance function. Once connected, we'll run the invoke DBA query to retrieve the specific data we want and mapped to each field we defined earlier. For this next section, you'll see that we're passing a null value to the password. That's because in our instance, we're not pulling in a plain text password. Instead, the database has a one-way hashed password, specifically a SHA-512 hash, meaning it's encrypted and not retrievable in its original form. Since we can't retrieve the original password, we're going to set it to null. Now, if we get results, we'll output an object that matches the account properties. Now that we've gone over the script, let's quickly see it in action. If you want to see it in a bit more detail, refer back to the previous video. So let's go back to providers and scan configurations to discover and import these accounts. And I'll click add new and select the AnyIdentity warehouse database as our script source. I'll name it and click OK. Once it's done, I see I found 3 accounts, so I'll click on it to view the results. Then I can choose to select some or all of them. I want to import all of these into my PAM vault. Then I can specify which folder I want them to go into. So let's put it in the warehouse database folder. And then finally, we can go over to the PAM vault and we could see that all the accounts were successfully imported there. Okay, moving on to action number 2. Now that we have our PAM accounts created, let's move on to the heartbeat properties and script. Now, the heartbeat is the action that reads the current password value of an account and compares it to the value stored by the PAM. So here, DVLS is expecting the script to return a Boolean value of true to let it know that the action has succeeded. Similar to the account discovery, we have a mix of properties, but here you'll see that we have additionally an ID and password properties tied to the account, since we're comparing the 2 passwords. Scrolling down, you'll see that just as before, we're using secure strings for password fields and running some standard checks, like checking for PowerShell 7.4 or later, verifying TLS 1.2, and confirming the execution policy is set to remote signed. Here, we also need the DBA tools module, and we also need to be able to create the SQL credential and connect to the database. Now, since the heartbeat operates on a single account at a time, we're going to have to perform some scripting magic and do a select query for the specific account ID and expect a single result. For the sake of time, I'm not going to go into every single detail, but basically we have to hash the plain text DVLS password, retrieve the byte array of that password, compute the hash, and format it to hexadecimal. Then we'll compare it to the stored hash in the database. If the DVLS hash matches the database hash, heartbeat will return true. Otherwise, it will throw an error. Okay, so to show this really quick, I can go back to my warehouse database and choose a user like S. Scott, and then there's a little icon up there for check synchronization status. If I select it, it will do the heartbeat and check the status of the passwords. Now let's take a look at the third action we want to perform, called password rotation. This is where we want to reset or rotate the password of both the privileged account and the one in the provider itself. So here, our script will need to accept a parameter called new password so that the password can be generated by DVLS at execution time. And just like in Heartbeat, it will expect a Boolean value of true to make sure everything ran correctly. Back in the AnyIdentity template, under password rotation, you'll notice here that many of the properties are very similar to the last 2 sections we looked at, but now we have a new password, which is a system-generated one, as required in our password rotation policies. And then we also have a single account ID specifying the user whose password we want to change. Like before, we're going to import all of the required fields. We're going to check for PowerShell 7.4, TLS 1.2, remote signed on the execution policy, and import the DBA tools to connect to the SQL. Then when we're connected, we're going to run an update query on the user ID to apply the new password. So basically in this process, we'll generate a new password using the hash SHA-2 algorithm. Then to accomplish this, we're going to first convert the secure string into plain text as it's required for the hash operation on the SQL end. And then if everything runs smoothly with no errors, we'll return true to confirm a successful password rotation. Now to quickly demo this, let me switch on over to the MS SQL database. And if I zoom in here to S. Scott's account, you'll see that her password hash is starting with a 2DE in it. Back in DVLS, if I go to S. Scott's account and I go to the options in the top right, I can hit reset password, which will go ahead and run that script. Now we'll go back to the SQL Server, and if I zoom in back here, you'll see now that S. Scott's account, she has a 96E in the password hash. So looks like everything worked correctly. Back again in Devolutions Server, we go to the Logs tab. We can see that the password reset was a success. Now, while I'm here, an additional thing I wanted to mention is the ability to set specific password templates. You can do this on individual accounts or like I'm doing here on the root. Depending on your organization, you might need to enforce specific parameters or policies for passwords. These are easily created, by the way, and edited by going to password templates in administration. Now, in this example, you can see that it requires a minimum of 20 characters, 2 of them being uppercase, a digit, and a special character, and so forth. There are plenty of other options that you can enforce to make sure that you meet your policy's criteria. Also, on the account level, if I go into the properties, there are additional settings like for resetting passwords upon check-in, and also for setting up a password rotation schedule with custom intervals. So to recap, we've just covered the core actions of the AnyIdentity provider: account discovery, heartbeat, and password rotation. Together, these features bring a new level of flexibility to managing privilege access, allowing you to maintain productivity while keeping your system secure. Now, if you found this breakdown helpful, make sure to hit the like button and subscribe so you don't miss the next video in our Devolutions PAM series. We're going to take it up a notch and dive into password propagation and how it keeps your privilege account passwords in sync across all connected systems. If you have any questions or want to see specific features in action, drop a comment below. The Devolutions team is always here to help. Thanks for watching.